Okay, so in the last video, we essentially went over this equation and how we come up with this equation of information as a function of probability is equal to negative log of probability. Please understand this before we move on with the next concept. Now, the next concept we're going to be talking about is what's called entropy, specifically Shannon's entropy. Okay, and this is given by the equation of H is equal to negative summation of Pi log Pi. Okay, so let's go back to information in general. Specifically, let's ask the question of what happens when there is a constant stream of information, or there's multiple events of information. For example, let's say we have an AI model that's reading some sort of context. Obviously, there's going to be multiple events or pieces of information in that context. So how do we deal with that? Well, we're going to deal with that with what's called entropy. Specifically, what we're going to be looking for is the average amount of information coming from a specific source. Okay, so let's get started by essentially deriving it. So first, let's go over expected value. Okay, so expected value, it's pretty similar. It's pretty easy to understand, right? The expected value of, let's say, a list of numbers, for example, right? Well, the expected value of that list of numbers is going to be the summation, right, of P of the probability of each number in that list or stream or whatever it is with X itself, right? This is the expected value. Is essentially how it works, right? So for example, let's say we have this input stream over here with the numbers 1, 2, 3, 4, 2, 3, 1, right? So what we see is this is a stream of 1, 2, 3, 4, 5, 6, 7 numbers, right? So it's a stream of 7 numbers, and 1 we see has 2/7 probability, 2, right, has a 2/7 probability, 3 has a 2/7 probability, and 4 has a 1/7 probability, correct? So the expected value of this essentially like input stream over here, it's going to be, well, the summation of each of these numbers times the probability of each. So it's going to be, or I mean, we can even say this in this example, for example, it's going to be 2/7 times 1 plus 2/7 times 2 plus 2/7 times 3 plus 1/7 times 4. Okay, great. So we came across this concept of expected value, and it's pretty easy to understand. So how can we apply this to information or a stream of information? How do we get the average surprise factor of information from a specific source? We apply a very similar concept. In fact, all it is just the expected value, but with subbing in information. So H is equal to negative, right? Negative summation, or actually here, if we just plug it into this here, it'd be this. It's a summation from, we have over here Pi, right? The probability of each number or symbol or whatever it is in that stream of information. And then we can sub in IP, right? And then we see there's a negative sign here, right? So we can put that negative out front, and then we come across the derivation of this. Okay, great. Now, you might be wondering, what the heck is the point of any of this? Well, I mean, think about it. The thing is when we have, some sort of input stream or some sort of information, what are we really trying to do? We're trying to reduce the uncertainty, right? An AI model, what is it doing? Well, what it's doing is it's trying to reduce the uncertainty in each output, right, that it brings, right? It wants to be as uncertain or as less uncertain as possible. Now we see here, entropy is really just a measure of uncertainty. In fact, in physics, entropy is known as disorder. In a context of computer science, it would be known as a state of, again, disorder or uncertainty, right? So that is why the concept applies to AI models, because we are trying to essentially minimize entropy, and we're going to see how that applies a little bit later. But this is how the derivation of Shannon's entropy works, and we're going to see how useful that can be in terms of training AI models later with other concepts like cross entropy.